So for this video presentation, let's try to describe fractional crystallization as a method in separating the components of a certain mixture. So let's have the following simple illustration to show how the fractional crystallization can be applied. So in this example, we have a container, and this container consists of seawater. Note that the seawater sample here consists of sodium chloride, magnesium chloride, and magnesium sulfate. And note that these three types of salts have the different values of solubility. Okay. Note that this seawater was actually subjected at a very high temperature. Okay. So we have the presence of heat in this example. So it was subjected at a very high temperature. And since it was subjected at a very high temperature, it means that these salts, sodium chloride, and magnesium sulfate, were actually dissolved. So these three types of salts were dissolved in this solution because they are subjected at a high temperature. Note that in the fractional crystallization, after it was subjected to a very high temperature, okay, it will be subjected to a very low temperature. So therefore, there will be a cooling process. Okay, cooling process will occur because it will be subjected afterwards at in a very low temperature. Okay, now if we have a very low temperature, what will happen is that there will be the formation of crystals. Okay, but among these three types of salt, magnesium sulfate is the first type of salt that will crystallize. Okay, why? Because it has the lowest solubility value, which is equal to 20. Okay, so once it was subjected to a very low temperature, magnesium sulfate will be the first type of salt that will crystallize. It will form the solid particles of magnesium sulfate since it has a very low, let's say, value of solubility. And take note, the lower the solubility, okay, the more it is insoluble, the more that it will crystallize in its solid phase. So in this case, magnesium sulfate will be the first type of salt that will crystallize because it has the lowest solubility value. Once we have the cooling process, once this solution was subjected at a very low temperature, so afterwards, okay, this solution will be filtered. Okay, it will be filtered. So therefore, we can recover magnesium sulfate once we perform filtration. So in other words, under fractional crystallization, filtration will be applied at the same time so that we can recover those crystallized salt. So in this case, magnesium sulfate was recovered because there will be the formation of crystals or salt. So therefore, what will be the remaining salt in this solution? Okay, so the remaining salts that will be present in this solution will be sodium chloride and magnesium chloride. Okay, so again, at this point, we have the other two remaining salts in the solution. And then again, after we have this process, okay, this solution once again will be subjected to a very high temperature. Okay, and then afterwards, it will be subjected to the cooling process. Okay, cooling process will occur once again. Once it was subjected to a very high temperature. So after that, it will be subjected to a very low temperature, the cooling process. And between sodium chloride and magnesium chloride, which type of salt that will crystallize first? Of course, the answer is, okay, the answer is sodium chloride. Why sodium chloride? Based on our solubility value, sodium chloride has a lower solubility value than magnesium chloride. 35.7 is less than 54.25. So therefore, sodium chloride will crystallize. So this will be the salt that will crystallize first. Okay? Once we subject it to a very low temperature. Okay? So, again, the process will be repeated once more. Okay? So, the sodium chloride will be recovered through the process of filtration. So therefore, we have the sodium chloride here. So in our third container, the sodium chloride was recovered. Okay? Then, the remaining solution here will be a mixture that consists of magnesium chloride only. So take note, sodium chloride here was recovered. Then the remaining salt will be magnesium chloride. So, again, to repeat once more the process, it will be subjected again to a high temperature. Then afterwards, it will be subjected to a low temperature once again. And there will be a cooling process in which magnesium chloride will crystallize. So therefore, crystallization always occur if we have a very low temperature. So again, for the last container, this solution, okay, will be filtered, in which magnesium chloride will be recovered. Therefore, the remaining content here will be water. Okay? So as you notice, we recovered the three types of salt present in a seawater once we subject them to a very low temperature. Okay? However, they differ in terms of solubility. So always remember, the substance that has the lowest solubility value will be recovered first. So in this case, magnesium sulfate will be the first type of salt that will be recovered since it has the lowest solubility value, followed by sodium chloride, and then the last one will be magnesium chloride since magnesium chloride has the highest solubility value. Okay, so that is the example of our presentation.